Good afternoon, students. We are going to discuss about invertible functions. As we have read about composition of functions, and invertible functions are related to composition of functions. Now, invertible functions means a function from x. If there is a function f from x to y, and that function is defined to be invertible if there exists a function g from y to x such that gof is equal to ix and fog is equal to iy, and the function g is called the inverse of f, and which can be denoted by f inverse. It means, let us define invertible function. A function f from x to y is defined to be invertible if there exists a function g from y to x. यहाँ पे जो है वो x to y है, यहाँ पे y to x है, and such that gof is equal to ix and fog is equal to iy, where ix and iy are identity set. The function g is called the inverse of f and is denoted by f inverse. Now we can say that if f is invertible, then f must be 1 1 and onto 1 1 and onto and conversely if f is 1 1 and onto then f must be invertible. And to understand better this invertible function, we have to take an example. Suppose that we consider an example. Let a function f from n to y be a function defined as fx is equal to 4x plus 3, where capital Y is equal to y belongs to n, such that y is equal to 4x plus 3 for some x belongs to capital N, and so that f is invertible. F is invertible, and also find the inverse. Now to solve this question, we have to consider an arbitrary element y of set y. Let us consider an arbitrary element y of capital Y, and by the definition of capital Y, we can write small y is equal to 4x plus 3 for some x in the domain capital N. For some domain in the capital N, and we can write x is equal to, from here we can write 4 x is equal to y minus 3, and this implies x is equal to y minus 3 upon 4. Now we can write, since a function g from y to n defined by gy is equal to y minus 3 upon 4. Now we have to show fx is equal to g of fx, and we can write here g of y, and y is equal to 4x plus 3. Y is equal to 4x plus 3. We have to put here fx is equal to 4x plus 3. Now we have gy is equal to y minus 3 by 4. Therefore we have to put 4x plus 3 at the place of y. Now this becomes 4x plus 3 4x plus 3 minus 3 upon 4, and this gives this is equal to x. Now this is identity element x and foy gy, fogy. We can write f of gy f of gy, and which is equal to f of gy is y minus 3 by 4. Y minus 3 by 4. But what is fx? We have to write y minus 3 by 4. We have to write here 4 into y minus 3 by 4 and plus 3, because y is equal to 4x plus 3. We have to put x is equal to y minus 3 upon 4 here. Now we can write y minus 3 plus 3, and which is equal to y. We can write here ix, and we can write here iy. Or this shows that GUF is equal to IN, because domain is IN. Domain is IN. GUF is equal to IN, and FOG is equal to IY. FOG is equal to IY, and this implies F is invertible. F is invertible and G is the inverse of we can also write G is equal to F inverse.